Okay, so we are going to talk about how to add and subtract fractions and mixed numbers today. So we're first going to talk about adding fractions, and we are going to do a little bit of adding fractions that are like and some that are unlike each other. So we'll have to make fractions become similar before we can add or subtract them. So kind of some basic rules that you guys should hopefully know when it comes to adding and subtracting fractions. Like I said, we're going to focus on adding first. If the denominators are not the same, you have to get them to be the same. And that's involving a little bit of what we've been talking about in like the last sections where we had to find common denominators by kind of thinking about like what would be the greatest common like factors between them, or like what's that least common multiple, like what's the smallest number they both can go into. So if you can find that, or if you can see it easily enough between the numbers that are in the denominator, then that's easy to do. Now if they are the same, so if you have the same type of fraction already, those are easiest to work with because you just go ahead and add or subtract them. Make sure for your final answer that it's in lowest terms. So if you get something after you add or subtract that can be reduced, you want to make sure that you're taking a minute to reduce it before you move on from that answer. All right, so for these first one, the first one already has common denominators. You guys see how they're both over 8? So we're just going to go ahead and add them. It's 3 over 8 and 1 over 8. So when you add fractions, you keep the bottom number as is. Don't do anything with those 8s. But we add 3 plus 1, which would be 4. Now, can you guys reduce that fraction, though? What do you do? And what do we get? Okay, so final answer there would be 1 over 2 or a half. Now, in the second one, they are not like fractions, but we should be able to get them to be like fractions. So I would look at the three numbers. You have 32, 16, and 8. Can 16 and 8 both get to 32 somehow? Yes, so I wouldn't do anything to the first fraction. So let's leave 5 over 32 alone. Now what are you guys going to take times the middle fraction to get the bottom? 2. How about the last one? Make sure you do that to the top and to the bottom. So the second fraction is now going to say 6 over 32. And then the last one is going to say 28 over 32. So 5 plus 6 would be 11. What's 11 plus 28? Good, so we have 39 over 32. So we could rewrite this if we want. I don't care so much if it's improper like that. If you guys leave it improper, I'm going to give you credit. Now, if the problem is asking for like a mixed number, then you got to change it. But if it doesn't specify and you have an improper fraction, you guys can leave it there. It doesn't bother me. If I wanted to change it, or if I was told that I had to change it to a mixed number, how many times can 31 or 32 go into 39? One time, and what would be the remainder? Good, 7 over 32. All right, let's take a look at the next example. Says that a plumber uses a 9/16 inch diameter copper tube wrapped with 5/8 inch insulation. What size hole must he bore in the stud to install the insulated pipe? Okay, so we've got the tube that's wrapped in the insulation, so you have to make sure that you guys think that 5/8 inch insulation is going all the way around that copper wire. So that 5/8, when we set this up, we're actually going to take that number times 2, because it's got to go all the way around the tube. So our copper tube is 9/16. So we're going to add that to the extra that we're adding with that insulation, so that we get the right size hole. And this is when I said you have to make sure that you take 5/8 times 2, because it's not just going around half the pipe, it's going around the whole thing. So you have to take that diameter into account twice. what would be 5/8 times 2? Not 10 over 16. It would be 10 over 8. Remember, 2 as a fraction would be 2 over 1. And when you guys multiply fractions, you multiply across the top and across the bottom. So 5 times 2 is 10. 8 times 1 would be 8. How can I get 10 over 8 to be like 9 over 16? So this is when you take the top and the bottom times 2, because you're trying to get like fractions. So we leave 9/16 alone. And now we have 20/16. So that's going to be 29 over 16. What would that be as a mixed number? How many times can 16 go into 29? Add 1, and 13 would be your remainder, so 13 over 16. Label would be inches, so that's how big of a hole he needs to drill in order to thread this through. Okay, let's turn the page. Alright, so far we've just dealt with fractions, like just individual pieces there, and sometimes we ended up with a number that was a mixed number because of writing it as with the mixed number kind of form. Now we're going to talk about adding mixed numbers. How do you add mixed numbers? So the first thing that you need to do is add the whole number parts, and then add the fraction parts, and do that the same way we were just doing it. If you have to change the denominators, do that first, and then add them. Then if you end up having like an improper fraction when you add the fraction parts, change that to a mixed number, and then if you have to, add that to the original number from the original mixed numbers, okay? So for example, we've got 5 2/3, 7 3/8, 4 1/2. So what I'm going to do is I'm just going to take all the whole numbers, the 5, the 7, and the 4, we're going to add those together first. So that's 16, you're saying? Okay, so I'm just going to want to leave that off to the side for a minute. Let's talk about the fractions. 2/3, 3/8, 1/2. What's going to be my common denominator? We can't go into 8. 24. Because all those numbers have to go into something in common. And 24 is going to be the smallest. Okay, there's other numbers, but they would be really big. So I would try to stick with like the smallest one that you can. So if we're going to take these all to 24, what do we take the first fraction times? How about the second one? And the last one? Okay, so now my new fractions are going to say 16 over 24, 9 over 24, 12 over 24. Now we add the top numbers. So 16 plus 9 plus 12. What's that? Okay, so 37 over 24. Let's write this as a mixed number. So how many times can 24 go into 37? Once. What's the remainder going to be? 13. So we put that over 24. Okay, and so why is it going to be 17? Right, so remember I did this portion first, and I said I'm going to keep that 16 kind of over here on the side. So now we have to take 16 and we have to add that to that fraction part. And this is what I said, sometimes you're going to get a mixed number, then you got to take that whole number portion and add it to the original. So 16 plus 1 and 13 over 24 is going to leave us with 17 and 13 over 24 for your final answer. Now, a lot of these rules that we just talked about apply when you're doing subtraction too. So if you're subtracting numbers or mixed numbers, the same process is going to happen. You've got to get those like denominators, and then you're able to combine it. If you've got the mixed numbers, you're going to follow some of the same steps. So in your guys' notes, you'll see that I've got like all the steps that you guys could follow when you're doing these problems. They're going to be a lot the same as what we've already done when we were adding. So I'm not going to go through and read that all over again to you guys. All right, so why don't you guys take a minute and try to do this first one. Get those to be like fractions, and then try to subtract them. So what's a common denominator? 32. So what do we do to the first fraction? So what's it saying now? 10. Okay. Can you reduce it beyond that? No. Number 5 is prime, so it's not going to have anything in common with 32 except for 1. And there's no sense of taking a 1 out, because you're just going to be stuck with the same thing. Okay, and then going into mixed numbers. So again, these are kind of all the steps to follow. There's a little bit more when it comes to subtracting mixed numbers, because there's going to be times that you're subtracting a fraction that doesn't have the same matching pieces. So we might have to do a little bit more work to get them to match before we can subtract. And now this is, of course, subtracting the long way. So getting those like fractions before we actually do our operation. So a lot of this, it's a lot of words. You guys can take a minute to read through those sometime. But I'm going to just show you guys some examples so you can kind of see when these different cases show up. Because there's a couple different things that can happen when we're subtracting fractions and mixed numbers. We're going to spend a lot of our time focused on subtracting mixed numbers in this area. And that's why I said there's just some different scenarios that can kind of happen. And I just want to show you a couple of those that you're going to see. So for this first one, I have 15 and 7/8, and I'm subtracting 4 1/2. So the first thing, kind of like what we did with adding mixed numbers, is I'm just going to focus on the whole number part. So I'm going to take 15 minus 4. What would be 15 minus 4? 11. Okay. So now I'm going to focus on the fraction. So the fractions are 7/8 and 1/2. What do I need to do to 1/2? By what? Okay, so then we have 7/8 minus 4/8. We get 3/8. So how would we write the final answer then? 11 and 3/8. Okay, let's look at a different one. This one wants us to do 15 and 3/4 from 18 and 1/2. So they don't have it just written out for you with the subtraction sign. Yeah, so if it helps you, I would write it out like that. So 18 and 1/2 minus 15 and 3/4. Okay, so let's see what happens here. If we just focus on the mixed number parts, let's take 18 minus 15. That's going to be 3. Let's take a look at the fractions. So we have 1/2 minus 3/4. Which fraction do we need to rewrite? The 1/2. So take it times 2. So now we have 2/4 minus 3/4. The problem with this one is I'm going to get a negative fraction. And then you'll have to figure out, like, how do I take that from that whole number part? So what we could do is, instead of subtracting the 18 minus the 15 and then doing the fractions, so I'm going to do this over here on the side. I'm going to show you a different method. Start by rewriting that 18 and a half. So take 18 and take away 1, so that you've got kind of this whole fraction part that you can kind of play with. So we write that as 17, and that whole number I'm going to put as 4/4. Because 4/4 would be 1, and then if I added it to 17, I'd be back up to my 18. Now we rewrote the 1/2 as 2/4, so I'm going to go ahead and keep that there. So I'm going to add that to 2/4. So what I'm doing is I'm rewriting this 18 and a half over here. So this is going to end up being 17 and 6/4. Now that looks kind of weird right now, but the reason why this is helpful is because now if I do my whole number parts, that would be 17 minus 15, which is 2. And now if I do my fractions, it's 6/4 minus 3/4, which would leave you with 3/4. So final answer is going to be 2 3/4. Now you could have gotten the same answer had you stuck with this original method, because what would be 2/4 minus 3/4? Negative a fourth. So what's 3 minus a fourth? 2 3/4. So you end up with the same answer as what I would have gotten here. If over here I did 3 minus the 1/4, I'm still going to get 2 3/4. This way just allows you to borrow from that first number and then subtract. Okay. Let's look at one more here. So we're taking 27 from 45 1/3. So again, we're taking 45 1/3 and we're subtracting the 27. All you have to do for this one is subtract the whole numbers. What's 45 minus 27? 18, and then you're still going to have just the 1/3. Because 27 doesn't have a fraction part, so it's like that 1/3 is subtracting nothing. So it just kind of tags along with the problem. All right, we got a couple problems left on the next page. All right, so 127 and a half pounds of sugar is used from an inventory of 433 3/8 pounds. How many pounds of sugar remain? Tell me what we're doing here. How would you set this problem up? Okay, so then we do this like we did before. What would be 433 minus 127? Shoot a calculator out and do that if you need to. And tell me what you get. 306? Okay, what are we going to do to 1/2 to get it to be the same as 3/8? Times 4? So my fractions, I have 3/8 minus 4/8. So we're going to get a negative fraction here. So it ends up looking like 306 minus an 8. What would that be? Good. 305 and then 7/8, because you're just taking away an 8 from that whole number. Okay, why don't you guys try the second one? How many feet of cable are left on a 100-foot roll if 27 1/4 feet are used? You know? What'd you get? You're close. It's not 73. 72 3/4. So you're taking 100 minus 27 1/4. If you wanted to, you could rewrite that 100 like I showed you on that problem before. So it says 99 and 4/4. If you don't want to deal with the negative fraction, minus 27 1/4. So 99 minus 27, that's how we get the 72. 4/4 minus 1/4, that's how we get 3/4. All right, for this next one, they've got it kind of combined where we're adding and subtracting. Remember, order of operations, you add first and then you would subtract. But let's try to get those fractions to be the same first. So look at those fractions. You've got a 3, a 2, and a 5 on the bottom. What's a number that they could all go into? Not 15, but 5 can't go into 18. 30. All right, so let's get these to all be over 30. So what would the new fraction say with the 5? What's on top though? Not 12. 5 is the whole number. And then what's the new fraction? 20/30 plus 1 and what? What does 1/2 become? 15/30 minus 3 and 12/30. All right, what's 5 plus 1? Minus 3. 20 plus 15 minus 12. So 3 and 23/30. Okay, we've got one more problem. And then we're done. 3 lengths measuring 5 1/4 inches, 7 3/8 inches, and 6 1/2 inches are cut from a 64-inch bar of angle iron. If 3/16 of an inch is wasted on every cut, how many inches remain? So let's break this apart into, we have like 3 lengths that they're cutting. And there's 3 cuts. And I'm saying that because we have to account for the waste that happens every single time. So the 3 lengths would be 5 1/4, 7 3/8, 6 1/2. And there's 3 cuts. Every single time is 3/16 of an inch that gets wasted. We're going to end up adding these two amounts together in order to account for like the total amount that got cut. And then we'll take that away from what we started with originally. So let's start on the 3 cuts portion. We've got 1/4, 3/8, and 1/2. What's the common denominator? And there's a smaller number than 16 that you could use. 8. So 5, what's the new fraction with the 5 if you change the bottom to an 8? What's on top? 7 3/8 stays the same. How about the 6 and... Okay, let's just focus on this area for right now. What's 5 plus 7 plus 6? 2, 3, and 4. Could be 19 and an 8. Now let's focus on the cuts. Instead of adding these 3, you could just take 1 times 3 if you wanted to. or you could add them. So the 3 cups would be 9/16. So we're going to take that 19 and an 8, and we got to add that to the 9/16 now. So 19 and the 1/8, we'll have to change that fraction again, because we're trying to add it to a fraction that has a denominator of 16. Now 8 can go into 16 2 times. So we're going to take this 19 and change that to a 2/16 plus the 9/16. So what's the total amount that we cut? 19 and what? Good, 11/16. Okay, now the problem's asking though how much remains. How much did we start with? 64. So we're going to take 64 and subtract the 19 and 11/16. If you need to, change 64 so that it says 63/16/16 so that you can subtract and not have to deal with a negative here. So what's 63 minus 19? $44. And then what would be the fraction? Our label would be interest. That's how much it's going to be left.